Hi, and welcome back to Algebra 2. Today's lesson is 5.3, the Laws of Logarithms. So we want to remind you that logarithms are basically exponents, okay? Not basically, actually exponents. So the laws of exponents that we've studied and used before apply directly to logarithms. So for example, if you take a look at our three laws here, you'll see how the product law actually has the exponent version I have there in the middle. So b to the x times b to the y equals b to the x plus y. Because when we have the same base, we keep the base and we add the exponents. Well, the same thing applies to logarithms. So if you slide over one more to where it says logarithm version, you'll see how it says log base b of x times y is the log base b of x plus the log base b of y. So we can constantly be breaking them up. And it might be a little strange at the beginning, but I promise you they will become as second nature as the laws of exponents are with you right now. All right, so the quotient is exactly the same. So b to the x divided by b to the y is equal to b to the x minus y because we subtract those exponents. And sliding over to the logarithmic version, we have log base b of x divided by y is equal to the log base b of x minus the log base b of y. The most important law that we use is the power law, and this is going to enable us to solve equations where the exponent is the variable. So we'll get into that a little bit in lesson 5.4, but for today we're going to look just at applying this. So when you have b raised to the xy, we multiply them. So it's b to the x times y. So when you look at the logarithm form of it, you'll see how it's log base b of x to the y. You throw the exponent out front. So it's equal to y times the log base b of x, because I'm going to remind you that that log base b of x is an exponent, so we just multiply them together. Once we show a couple of examples, hopefully you'll be a little bit more comfortable with using them. All right, so we're going to move on to exercise 1. Exercise 1. Which of the following is equal to log base 3 of 9x? So we're going to do some applying of our laws. So this is multiplication, 9 times x. So this is going to be equal to log base 3 of 9 plus log base 3 of x. And this one here we can simplify because I'm going to remind you what this means. This means 3 to what power is equal to 9. So this is going to be 2 plus log base 3 of x, which is right here. In exercise 2, the expression log base 10, right? There's nothing written there, so that's natural. That's a common log. So log base 10 of x squared divided by 1,000. So again, we're going to break this up into log of x squared minus log of 1,000. So we're going to use the power law right here. And we're going to kick that 2. This is what I'm saying. This is going to become a little second nature to you. So we kick that 2 out front. So it's 2 log of x minus, now this we can evaluate. This means 10 to the what power is equal to 1,000. And hopefully you remember my little trick by counting the zeros. So it's minus 3. So 2 log x minus 3. So here it is right here in number 1. Exercise 3. If if a is equal to log of 3 and b equals to log of 2, then which of the following correctly expresses log of 12 in terms of a and b? So basically what that tells me is I'm going to rewrite 12 in terms of 2 and 3. In terms of 2 and 3. Because the first time I looked at this, I thought to myself, well, the log of 12 is the same thing as the log of 4 times 3, but 4 doesn't help me. So this is what I thought, my first thought. 4 times 3, but then I realized 4 I have to rewrite as log of 2 times 3 in order to use my a and b as defined here. So when I take this piece right here now, this becomes the log of 2 plus the log of 2 plus the log of 3. And this works the same way as variables. I have a log of 2 plus log of 2, which is 2 logs of 2 plus log of 3. Log of 2 is A. I'm sorry, log of 2 is B. So it's 2B plus A. Don't make that mistake, because that answer, I'm sure, is there. 2B plus A, 2B plus A, or A plus 2B using the commutative property would be the correct answer. The way I almost made the mistake, I might have chosen C, because, you know, all of a sudden it starts making sense that you make the A the 2 and the B the 3, because you're kind of putting them in order. Your brain does funny things that way, so make sure you're double checking it. Okay, so how are we feeling? Outstanding. All right, so moving on. We're going to look at exercise 4. So which of the following is equivalent to log base 2 of rad x over y to the 5th? So the first thing, I'm going to keep reminding you, logarithms are exponents. So we're going to change things to exponent form. So the first thing I'm going to do is I'm going to rewrite this. I don't like the way this is written. So I'm going to rewrite this as log base 2, and I'm going to write it as a fraction this way. So I'm going to rewrite x as x to the 1/2 over y to the 5th. And again, I keep telling you, sometimes if you just rewrite things in your handwriting, it looks much friendlier. So the first thing we're going to do is we're going to break it up because we have division. So this is going to be log base 2 of x to the 1/2 minus log base 2 of y to the 5th. Now we're going to use our power laws, and we're going to throw those exponents out front. So we get 1/2 log base 2 of x minus 5 log base 2 of y. Do we have that here somewhere? Good. Here it is right here, number 3. The reason I keep saying do we have it, because sometimes you'll see we need to manipulate it. I think in exercise 5, you'll see what I'm talking about. So in exercise 5, we're going to do the same thing. We're going to rewrite this as log base 3 of 5 to the 1/2 over 27. So what does that equal to? It's equal to log base 3 of 5 to the 1/2 minus log base 3 of 27. Well, just slide this down a little bit, or up. All right, so now let's pull those exponents out front. So what I mean is that we're going to take those exponents, throw them out front. So this becomes 1/2 log base 3 of 5 minus, and there's nothing to pull out front here, but I can evaluate this because this is telling me 3 to the what power is 27, and the answer is 3. So there's a 3 here. So this is what I'm talking about. When I look at my answer choices, none of them are equal to this. So you have to figure out which one this is. So maybe you're better off starting with your answer choices. So when I look at 3 here, because 3 looks like it has a good possibility of being my answer. So what does this mean? This means, let me just use a different color so you can see. This means log base 3 of 5 over 2 minus 3 over 2. That's what that means. Now, is that what I have? No, it's not. So this is not my answer. All right, and looking at it, even if I multiply through by 4, I'd have to multiply through by 4 to get a 2 out front here. So I know these two are not the answer. So this last one is equal to log base 3 of 5 over 2 minus 6 over 2, which is equal to 3. So there's my answer. All right, because when you take log base 3 of 5 and divide it by 2, that's the same thing as multiplying it by 1/2. Hopefully you recognize that. Okay, now, in exercise 6, who remembers composition of functions? All right, because everything that we've done before is going to come back. Whenever we introduce something new, we're going to go back and kind of roll it into what we already know. So f of g of x is a great example because this is telling me, number 1, So I can test two different concepts with this. Do you understand logarithms and the laws of logarithms? And do you understand the composition of functions? So this is a great question. So this is f of g of x, which means I'm starting with my g of x, and I'm putting it in where the x is for my f of x. So this is going to be log of 100 x cubed. So all we're going to do, look at the answers, they're not there. So let's break it up using our laws of logarithms. So we're talking about base 10 here. So log of 100, you don't even need to have it in parentheses. Okay, so log 100 plus, now if you want to, you can skip this step now and just throw the exponent out front and say 3 log of x. But let's not skip steps yet because I don't want to confuse you. So this is log x cubed. And then in our last step, we can do some evaluating because log base 10 of 100 is 2 zeros, all right, plus 3 log of x. So 2 plus 3 log of x, here's my answer right here. So hopefully this is getting a little bit easier for you as we do these different problems. So let's take a look at exercise 7. The logarithmic expression log base 2 of rad 32 x to the 7th can be rewritten as. Now, let me remind you of this, that you are never going to have a logarithm under a square root sign. So right away, I can take these two out. I know they're not my answer, but let's see why they're not our answer. So we have log base 2, so we're going to rewrite this. And beware when you rewrite this because this gets a little bit tricky. So this is log base 2 of 32x to the 7th, the whole thing raised to the 1/2 power. So because the whole thing is raised to the 1/2, we can use our power law and we can kick that out front. So 1/2 log of 32x to the 7th. I'm going to remind you kind of that you're going to, basically that 1/2 applies to everything behind it. All right? So we have, now we're going to do something with this. So this is 1/2 log of 32 plus, and now this is where it gets, you start getting really fancy because you can just kick that 7 out front, log of x. All right? So I skipped a step there. Hopefully you're comfortable with that. I pulled that exponent, so I applied the power law at the same time as the product law. So now, as soon as you get something that looks like this, and I'm sorry, I'm forgetting my base 2's here, because I saw this 32 and figured it had to be base 2, because 2 to the what power gives me 32? 5, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, plus 7 log base 2 of x. And another way to write that is the whole thing divided by 2. So our answer is right here. Last one, exercise 8. If log 7 equals k, then log 4900 can be written in terms of k as. So we're talking about a common logarithm here. So think about what this is going to be. So log of 4900 is equal to, right away, it's 7 times 7 times 100. Like it sticks out in your head that 7 times 7 is 49 times 100, which is going to be fine because in a common logarithm, I know that the log of 100 is 2. So I can rewrite this as the log of 7 plus the log of 7 plus the log of 100, which I know is 2. And I know the log of 7 is k, so k plus 2 is 2k plus 2, and I don't see that anywhere, but obviously if we distribute this, we get 2k plus 2. So that's another little trick that math teachers and Regents exams play, is that, they know how you're going to get your answer, and they don't put that exactly in the multiple choice questions. You have to manipulate it just a little bit. Again, it's just testing one more concept. You understand how to recognize that 2k plus 2 is the same thing as 2 times the quantity of k plus 1. All right, and as you get into upper level mathematics, you're going to be surprised that those concepts are there. They're there, and you'll be able to, um, easily manipulate between the two forms. All right, so like I always say to you, we're done for today. Always make good choices, and we'll see you next time.